Hi, I'm Marissa and I'm with the Circor Zenith Gear Pump team, and I'm going to be presenting our poster for this year. Here's just a general overview of what our poster looks like. So our project objectives were to analyze the Circor Zenith Gear Pump using CFD. We needed to document the entire process so it could be easily replicated. We needed to build a leakage calculator. We chose to do so in Excel, and that would show any leakage results from the CFD simulation and also testing that was done in-house at Circor. And we also needed to focus on low viscosity fluids. For the project specs, we did a CFD simulation that analyzed the different slip paths, which will be discussed in coming slides. And again, we also completed documentation that covered the entire process and will act as a manual for those who want to replicate this process. To try and troubleshoot problems that we were having with ANSYS, we decided to go about modeling a cylindrical pipe and doing a CFD simulation on that. We also did a dimensional analysis to verify against hand calculations that we did. Figure 1, you can see the named selections boundary conditions, which were applied to this model. For the applied methodology, those were basically just any inputs that you had to put into ANSYS to run the simulation. That includes boundary conditions, pressure and velocity conditions, fluid properties, and the radial revolution from momentum balance equations, which converted xy coordinates to radial coordinates. And you can see in figure 2 the velocity profile for the test pipe. Meshing was a crucial point for the simulation process since the meshing accuracy determined the result and quality of the simulation. It was very time consuming and complex, and the most important step in the simulation process. And you can see in figure 3 that we had a high orthogonal quality mesh for the radial cut. As I mentioned previously, we had 3 different slip paths, the first being the gear face. You can see this modeled in figure 4. The second is an individual gear tooth, that's in figure 5, and that's just the gap between 2 gear teeth that the fluid would sit in. And then we also had a bearing, which is just that straight piece in figure 6. We also had a radial cut, which combined all 3 paths, but we had a lot of problems with that, getting it to mesh properly, so we decided to just split it into 3 different models. One of our deliverables was a leakage calculator, which we developed using CFD data. It accounts for various fluids and manufacturing variability. As you can see in figure 7, there is a list of different fluids. And we also used the in-house testing provided by Circor to verify our results. You can see in figure 8 that we have different inputs that calculate the total leakage. And these are just our references that we used for our project. Thank you.